things, but my mic here is not like the greatest mic, so FYI, I would rather you just pay attention in class than listen to the recording, okay? But I did it in second period, the recording worked. I'm doing it again just so maybe I'll get something better. But FYI, I would use this as a reference, okay? But I would really rather just you listen in class. All right, if you plug in 2 here, you guys good plug in 2? If you plug in 2 here, what do you get? 0 over 0, okay? Then you say to yourself, oh, gotta do something else. What's your first something else? Can I factor here? I certainly can. What goes out of this numerator? X. So this becomes x over x minus 2. On the bottom, if I factor, what do you get? X minus 2 and x plus 1. But don't forget, the bottom has absolute values. And this is still a limit as x goes to 2 from the left. All right, guys, the whole reason you factor is that you're hoping that something will cancel out. Sometimes nothing will cancel out. But if something cancels out, then it's kind of takes you ahead a little bit. Does anything cancel out here? Yes. What? X minus 2. What does it cancel out to, though? It doesn't just disappear. 1 or negative 1. Do you see it could be negative 1 in this case? Why? Because there's an absolute value here, and you've got something coming from the left. So let's look at this. Do you see that this part that's circled is either 1 or negative 1? Which one is it? Negative. Okay, it's negative 1 because the bottom holds positive. You guys good with that? Because it's an absolute value. The top, I'm going to plug in a number that's really close to 2, but I'm coming from the left of 2. What's a number to the left of 2? It's really, really close. 1.999. If I plug in 1.999 here, do I get a positive answer or a negative answer? Negative. So it's negative over positive, which will be negative 1, which means right here, this limit is actually the limit as x goes to 2 from the left of negative x over the absolute value of x plus 1. Do you guys see where I'm getting this? Okay? It's okay to put an equal sign here because the limit of this is equal to the limit of that. Okay? Had I not put limit, then of course it wouldn't have been correct. All right, so let's go ahead and see if I can maybe at this point plug in. What would I plug in? 2 or negative 2? Be careful. 2. Do you guys see that negative sign is not negative 2? Is everybody good with that? That is 2 coming from the left. So I'm going to plug in 2 here and 2 here. So do you see my answer is negative 2/3? Okay, any questions on how to do this? All right, hopefully you can do that on your own. We're also going to do this problem here. And let me tell you, I've told you way more on this problem than you'll get on your test. Okay, on your test, can you guys take a look at your homework from last night? Your test is going to look like number 1, 2, or 3 on your homework last night. Okay, all it will say is find the horizontal asymptote for g of x. And for g of x, it's going to say equals x cubed minus 7x plus 10 over e to the x plus x minus 1. Okay? And in your mind, you're going to say, oh, okay, to find HJs, I take the limit both ways. Okay? Which means you could have 2 different answers on this homework. Is everybody good with that? Actually, you should have 2 answers. If the answers are the same, then you have 1 answer. Does that make sense? If the answers are different, you have 2 answers. If one is D and E, the other is 5, then you have 1 answer. Does that make sense? If both of them are D and E, and the answer D, you have no horizontal asymptotes. Is everybody good with that? Okay? So the most you could get is 2. The least you could get is 0. But you have to do both. So on your test, I'm looking, do you understand that you had to take the limit both ways? If you only showed this one, which is what most students do, actually most students pick the one that they want to do. Okay? You can't do that either. All right? You got to show both the limit to infinity and the limit to negative infinity. And I'll be like, okay, at least you set it up right. Okay? So FYI, let's say you don't even know how to figure this out. If you set it up right like this on the test, you've already got a point. Does that make sense? Okay? So there's a lot of partial credit on the test. All right, so if I take a look at this, I'm going to plug in infinity. And let's think about how to plug in infinity. If I just look at the numerator, if I plug in infinity here and infinity here, which one, is the dominant one? Which one's the dominant one? X cubed. Do you guys see that? And so actually what happens is this is negligible and this is negligible compared to infinity cubed. Does that make sense? I'm not saying that this is small. It's pretty large. But compared to infinity cubed, these are negligible. Let's look down here. Guys, if I put an infinity here, which one's going to be the dominant one? E to the x. Do you see that? Okay, this will be e to the infinity. This will be infinity. This will be 1. So not to say that infinity is not big, but compared to e to infinity, this is negligible. So you could rewrite this problem as this problem here. And guys, on your test, you will have a problem as simple as this. And students have a hard time with this. Do you remember how to do these problems? You just need to figure out smaller or bigger or small. Can you tell which one's bigger and which one's smaller? Yeah, how? Do you remember the rules, like the order? Okay. What's the smallest one? Do you remember the smallest one is a constant or sine x or cosine x? What's the next in line? I think it's ln of x. And then what's the next in line? X, and then x squared, x cubed, keep going. And then next in line, e to the x. Actually, 2 to x is probably smaller, right? Because e to the x is like 2.7. E to the x, then maybe 5 to the x, then maybe 100 to the x. Does that make sense? It goes on forever. All right, so looking at this, which one's bigger and which one's smaller? E to the x is bigger. So guys, do you see this is really a small over big? So this answer is 0, okay? So on your test, I am looking for y equals 0. If you have just 0, I'll count it right. But if I'm looking at your test and you have 0 and -3 and -2, and you have all sorts of answers, you're hoping one of them is right. And I'm looking at your test, I'm saying, you know, I don't think you really know what you're doing. Even if you have the right answer, guys, I'm not going to count it right. You got to look like you know what you're doing on the test. Does that make sense? So if you want to clarify, if you're like, you know, I think Ms. Chang's not going to know what I did. If you want to clarify, box it in. Okay, if you want to clarify, box it in. And I'll take either one of these answers. But if you have lots of answers, nothing's boxed in, okay, I'm just going to figure out, it'll be up to my discretion. Do you really know what you're doing or not? Okay. On this side over here, there could possibly be another answer. Just look at this. If I plug in negative infinity, okay, now guys, negative infinity is not a number, all right, but let's just think conceptually. If I plugged in negative infinity, do you see that this would be like negative infinity cubed, right? Negative infinity times negative infinity times negative infinity. It's going to be a negative. It's going to be cubed. This here is going to be plus 7 infinity. Do you see that? Okay, again, guys, I'm plugging in infinity so we can kind of visualize it. But the truth is, you cannot plug in infinity. And later on, when we get to some things that are a little bit tougher, I'm going to teach you guys how to express this, okay? Because if you put in infinity, you'll actually get it wrong when we get in later on in calculus when we do integrals, okay? And then plus 10 is pretty small. Guys, between these two, which one trumps which one? Which one's going to be the dominant one? Negative infinity cubed. Okay, I know it's the smallest one. I know it's super, super small, but it's still dominant. Does that make sense compared to this? All right, so what I'm going to do is I'm going to say this is negligible and this is negligible. Okay, now this is where things get tricky. Guys, if you know the x function, which you should, okay, when x goes to infinity, what does e to the x go to? Okay, it goes to infinity. Okay, guys, when x goes to negative infinity, what does e to the x go to? 0. Do you see that? So when I plug in negative infinity here, which one's the trump factor? Which one's the dominant one? It's the x. This actually goes to 0. It's actually quite small compared to negative infinity. Okay? So what I really have down here, so let me rewrite it, is a limit as x goes to negative infinity of x cubed over x. Those are the dominant terms, okay? And if I solve this answer, I'll have this answer, okay? What is this equal to? Yeah, I mean, if you want to be technical about it, you could say that this up here is negative infinity, and this down here is negative infinity. So it's actually positive infinity. But if you're not super sure about it, D and E is always right. Are you good with that for a limit? So you can put D and E. All right. So guys, what are my horizontal asymptotes for this function? Y equals 0. Right? I only got one answer. Possibly I could have gotten 2, but I only got 1 here. All right. So guys, on your test, if you write this answer and I don't see any test for the limit to negative infinity, okay, then you only get partial credit. Does that make sense? Because I know you got the answer right, but you didn't test for both sides. Okay, so make sure you test for both sides. And let me just add something just for fun. What is a vertical asymptote? What is a vertical asymptote? So to find HAs, I take the limit both ways. To find VAs, remove the holes, bottom 0. Okay? So guys, I'm going to take this function, I'm going to take out the holes. To take out the holes, I have to factor. Okay? Factorable or not? Don't do it. It'll hurt too much. Okay. So guys, what you're going to do is just set the bottom equal to 0. Okay? So I'm going to set this equal to 0. So what x value, okay, makes this value 0? Okay, and it's not an easy problem, but let me just kind of give you the answer. Just if you guess and check. Do you see if you plugged in 0 here and 0 here? Plugged in 0 here and 0 here, would you get 0? Yeah. What's e to the 0? It's really 1. So 1 plus 0 minus 1. So actually, x to the 0 is a vertical asymptote. All right. If you pull up the graph for this function, this is what it would look like if you put it into your calculator. And let's see if everything that we did worked out. As x goes to infinity, remember we got the horizontal asymptote y equals 0. Is there a horizontal asymptote of y equals 0 here? Yes, right? Remember when we went x equals negative infinity, we got the horizontal asymptote of d and e, right? Or, did we say positive infinity? I hope. Okay. Is this going to positive infinity? Is that the limit? Yes. And what did we say our vertical asymptote was? X equals 0. Is that x equals 0? Yes. So this picture matches the things that we figured out. Yes, Grant?
So if we weren't to remove holes, would they just cancel out? Like
Yes,
you
they
could
would
still
cancel out.
find the vertical asymptote without removing the holes?
Well, the thing is, you don't want your hole, you don't, like if you had a hole, you'd have x minus 3, x plus 5 over x minus 3, right? Okay, so if you remove the holes, there is no vertical asymptote in this picture. If you don't remove the holes, you might accidentally think that x minus 3 equals 0 is a vertical asymptote when it's not. Does that make sense? So you want to remove the holes first, if there are holes. Okay. All right, guys, pass up your warm-ups. And let's go on to your homework from last night. So pull out your homework, guys. Number 1, the answer should be 3 and 3. So your answer should be y equals 3. Okay? Guys, number 2, your answer should be 2 and negative 2. Okay? So you should have y equals plus 2 and y equals negative 2. All right? Number 2 on your homework. Number 3, your answer should be y equals negative 1 and y equals 5. Okay, y equals negative 1 and y equals 5. Check your answers, guys. That's number 3. Okay, number 4, on your left side, just going down, should have 0, 1, d and e or positive infinity, 0, negative 2/3, and d and e. That's on the left side. On the right side, you should have 2/3, 0, negative infinity or d and e, negative 1, negative 2, 0, and number 12 is also 0. Okay, so check your work, guys. And what questions do you guys have on your homework? Yeah, Miriam?
5.
Number 5. Okay, where's 5?
It says 4A on it, but it's
Oh yeah, 5A or 5B or 5C? This one right here?
any of
5A. Okay. On 5A, the trick here is going to be seeing that this is the leading term and this is the leading term. Then you look at the exponent. This exponent is actually 1.5. This exponent is actually 2. So this is a small overbid. Okay. What other questions you guys have? Grant?
Could you do 9?
Number 9. Okay. Yeah, number 9 over here. If you plug in infinity, on the top, this is going to be the dominant term. On the bottom, though, this x is going to be negligible compared to infinity squared. So the equivalent to this is the limit as x goes to negative infinity of x over the square root of x squared. But what is the square root of x squared? X absolute value. So what I'm going to do is I'm going to replace this with x absolute value. So really what I have is a limit as x goes to negative infinity of x over x absolute value. And I'm going to tell you that answer is either 1 or negative 1, and you have to figure out which one it is. Can you do that? Can you go from there? Okay, what is the answer, guys? Negative 1. All right. What other questions do you guys have? 12? Okay. So, guys, if you move down to 12, okay, this is a trump question. So example, 1 is a constant. So remember, constant, cosine x, sine of x. And then, what was the next one? Ln of x, and then x. Do you guys remember this? And then x1, x2, x3. This is really x1. And then e to the x, 5 to the x, 10 to the x. Okay. This 1 is a constant. So do you see it's on the lowest on the totem pole for growth? Okay. What about 2x? 2x is right here, right? I know I have it twice. But 2x is right here. So 2x grows. Okay. What about sine x? Pretty low on the totem pole for growth. Okay. But while this one's not growing and this one's not growing, the 2x is growing. You guys see that? So at the bottom gets bigger and bigger and bigger. What you have is a small over big, which is 0. Okay? Yeah, lots of logic in this problem. I can't tell you, for this problem, you're always going to do this. Okay? You're going to have to always like kind of think about, hey, what happens when things grow? Okay, yeah.
So number 11 is small over big as well?
Yeah, number 11 is small, beautiful, small over big as well. Exactly. Yes. Okay, what other questions do you guys have? Yes.
Number 3.
Number 3. So guys, we're looking at number 3. Okay, this is your number 3. I know it doesn't look like number 3, but it is. I think. Can you check that? Is that right? Okay. So what you're going to do is it says to find HAs, you take the limit both ways. So I'm going to take the limit as x goes to infinity, and I'm going to take the limit as x goes to negative infinity. And guys, on your test, if this is all you write, you already have 1 point. Is everybody good with that? I'm looking, do you know you're supposed to do both of them? When I plug in infinity here, 2 raised to the x is almost like e raised to the x, if you think about it. It's, e to the x is 2.7 raised to the x. The figure looks the same, even though it's not exactly the same. As x gets bigger and bigger and bigger, this is going to go to infinity, or d and e. As x gets smaller and smaller and smaller, this is going to go to 0. So everybody good with that? So if I plug in infinity here, which one's going to be more dominant? Like which money would you rather have? Or which one's going to affect the numerator more? 2 raised to the x. So this is actually negligible. Okay, the 5 is actually negligible. And using the same logic, this 1 is actually negligible. Okay, so the real problem I have here is a limit as x goes to infinity of 2x over negative 2x. And you really just need to plug in here. If I plug in 10,000, I get 2 to the 10,000 over negative 2 to the 10,000. What's that answer? Negative 1. Like what if I plugged in a gazillion? So here's a gazillion. What's the answer? Negative 1. Do you see it's always negative 1? Okay? Some of you guys look like you don't believe me. Put in a gagoodle trillion. Okay? What's the answer? It's still negative 1. So this answer is negative 1. Or you could say the horizontal asymptote is y equals negative 1. Now, where did that 1 come from? It's kind of the same as, remember when we talked about if the powers are the same, if your leading terms, these are actually your leading terms. If the powers are the same, take the ratio of the coefficients. And it's not really written explicitly in here, but there's a coefficient here of 1, and there's a coefficient here of negative 1. And that's where that negative 1 came from. It's actually a ratio of coefficients that's not real explicit. Okay, if we go to this negative infinity, though, something weird happens on this side. Which one's going to be more dominant, the 5 or the 2 raised to the x? The 5. Because when you plug in negative infinity into 2 to the x, you get 0. So this becomes 0, and this becomes 0. So 5 plus 0 is 5, and 1 minus 0 is 1. So your answer on this side is y equals 5. Okay, weird, spooky, Halloween's coming. Okay, all right, you guys good on your homework? All right, let's move on. I like to talk about some trig that you need to know. You need to memorize these 2 limits, okay? They were on your homework maybe 2 homeworks ago, either Wednesday night or Thursday night, I don't remember. But they were on your homework. You figured it out with your calculator, and now you're just going to memorize it. Those of you guys who know L'Hopital's rule, okay, you can do it using that too. I'm okay with that. But most of you guys probably don't know L'Hopital's rule, so you're going to memorize it. Eventually we'll use L'Hopital's rule to do this. But right now you're going to memorize it, okay? You're going to memorize it because if you have this on the test, You need to know how to do it. The other thing I want to add to this, I want you to not get confused between this problem and this problem. This is to 0 and this is to infinity. Okay, I think you had this problem last night, or a night before. You had this problem. Yeah, I think you had it last night. Okay, what was the answer to this? Remember, this is like sine of x, which moves like this. This is like x, which moves like this. Okay, so what's this answer going to be? 0. It's going to be small over big. This is small over big, which is 0. Okay, so guys, memorize this. If it goes to 0, the answer is 1. If it goes to infinity, though, the answer is 0. Okay, and calculus, you got to pay attention to the details. All right, and then something else I need you to understand is that with limit properties, actually, I don't know if it's limit properties, but with limits, if you have a very clean fraction like this, if I flip this, then I can just flip this. You can do that in limit land, okay? So guys, if this is the limit, sorry, I did this wrong. I'm not going to infinity. I'm going to 0. Okay, if I take this same problem and I flip this, what's 1 over 1 flipped? 1. So this is also 1. So I need you to understand that. Even if I flip this, you're going to still get 1. Okay? And I think we talked about this yesterday or Friday, I'm not sure. But if you put a 5 here, as long as this is the same as this, the limit is also 1. Okay? So if I put pi x here, and this is pi x, the limit of this sine pi x over pi x would be 1. As long as these are the same. Okay? Yeah, Miriam? Yeah, go for it. Okay, the other thing you need to know is memorize this. Now you need to know that this flip doesn't work though. Okay, so for example, if I did the limit as x goes to 0 of x over 1 minus cosine x. Okay, if I flip this, what's the flip of 0 over 1? 1 over 0, which is undefined or D and E. So guys, this would be 1 over 0 or undefined or D and E. Okay, whatever floats your boat. Okay, but this is not as nice as flipping this one. This one stays 1. Okay, so all those things you need to know, memorize that. You also need to memorize, it's a while, so hard. Sorry about that. Let's just do some problems first. Make sure you understand it, and then I'll show you some other things. All right, guys, this right here, do you see it would equal 1 only if this matched with the bottom? You guys good with that? Okay, but here's the thing. I can't just put 4 on the bottom. If I put 4 on the bottom, if I multiply by 4 on the bottom, what do I also have to do to the top? Multiply by 4. If I put a 4 down here, make sure I put a 4 up here. And limit properties tell me if I have a scalar that's multiplying this whole algebraic expression, I can pull the scalar out to the front, right? And I know what this answer is. What's this answer? 1. So this is 4 times 1, which is 4. You guys see how that works? And I think a lot of you guys kind of know the shortcut to this too. But this is mathematically why this answer is 4. I mean, what if I took this and I flipped this? Now I have x over sine 4x. Well, same line of thinking. I really want these to be the same, right? Because then the answer will be 1. But if I multiply by 4 on top, I also have to multiply by 4 on the bottom. So I'm going to put a 4 down here, okay? Now here's the thing. I'm going to pull this scalar out, this 4 out. When I pull this 4 out, it's not going to be 4. What's it going to be? 1 over 4. Is everybody good with that? Because the 4 is on the bottom. So this is going to be 1 over 4 times this limit. This limit is going to be 1. So I have 1/4 times 1, which is 1/4. Are you comfortable with that? Okay? Let's do something a little bit different. Let's look at this problem here. Guys, if I have 5x here, what do I want in the denominator? 5. Not just 5, but 5x, right? So there's already an x, so I'm going to multiply by 5. If I multiply by 5 on the bottom, I also have to multiply by 5 on the top. It is a multiplication. Scalar limit properties tells me I can move this to the front. Do you see that? So this is going to be 10 times 1, which is 10. Okay, are you okay with this? It's not really hard, but if you're missing some small link, it's going to be tough for you. Okay? All right, let's move on. I'll post these notes, and hopefully that will help you. This is the other thing you need to memorize. Okay? You need to know all of your pre-cal properties, the trig properties, okay? Identities, these are all the Pythagorean identities. These are the definitions, okay? I'm going to assume you guys know this coming into the class. Yes?
We're memorizing this for the test?
For the test. For the test. Yeah, not for the quiz. Ooh, possibly for the quiz. There is a cosine sine problem, but I can't remember if you have to change it or not. Okay, but definitely for the test. Okay? It should not be a big curve to memorize that, guys. That should be something that's just definition-wise that you know. All right, so let's start this problem here. Guys, if you plug in 0, do you see that I will get 0 over 0? Okay, so I say to myself, oh, gotta do something else. I'm going to try to factor. Does factoring work? No. What about conjugate pairs? I don't see two things added like some sort of binomial. Okay, what about common denominator? Not really. Okay, what about multiply out and simplify? Are there parentheses I can get rid of? No. So I'm going to have to be smart. I'm going to have to say, you know what? I know that tangent is cosine x over cosine, sine x over cosine x. And if I know that, I can rewrite this problem, okay, as sine x over cosine x times 1 over x. Okay, dividing fractions, easy as pie. Flip the second and multiply. Do you agree with that? Okay. If that's true, I can identify something that actually makes me very happy in here. Does that make you happy? What is the limit of sine x over x? 1. So this is really the same as a limit as x goes to 0 of 1 times 1 over cosine x. Right? It's really 1 times whatever I have. Okay? Well, if I plug in 0 here, what's 1 over cosine of 0? Cosine of 0 is really 1. So 1 over 1 is really 1. And so you see the answer here is 1. Okay? Yeah, Brant?
Can you say that again?
Say what again?
Way over my head.
Okay, this part here?
Yes.
Do you see that this is 1? Because we've memorized that. The limit as x goes to 0 of sine x over x, that is 1. That's 1. So here it is, 1. Right?
Yeah.
Times the limit of 1 over cosine x. See, that's what I have left over.
Okay.
1 over cosine x.
Yeah,
And then
I was
I just plug in.
I was confused
see
because
that?
I thought, like I usually think of whenever you do that, there's an equal sign between.
Right.
You just,
Right.
I got
You're
it.
good. Okay, good. If you're asking, Brant, someone else is asking. Okay, let's look at this problem. A little bit more difficult. Okay. Very similar problem, though, guys. This tangent of 5x, you really need to understand that that's the same as sine 5x over cosine 5x, right? Yes? Okay. So this is the same as a limit as x goes to 0 of sine 5x over cosine 5x times 1 over 3x. Do you agree with that? Do you see anything that makes you happy? Kind of. I have a 5x here. What do I need on the bottom? A 5, right? Because I already have an x, right? So let me just move this 3 over and put it a 5x, right? Can I do that? If I do what? If I multiply the top by 5, right? I haven't changed the value of the algebraic expression, okay? Something happy, okay? Something happy happens right here. What is the limit of sine 5x over 5x? 1. So what I have here is a limit as x goes to 0 of 5 times 3 cosine 5x. I moved the 3 to the front just so that we don't accidentally multiply by the 5x. Is everybody good so far? You guys ready to plug in? If I plug in at 0 here, what do I get? You guys good? Does everybody see where you get 5/3? Cosine of 0 is really 1. Okay, so the answer is 5/3. Okay, I feel like I'm not getting a lot of response. So I'm thinking that it's getting a little tougher for you guys. Okay? Likewise, guys, if you're trying to find a limit of something like this, okay, first you're going to plug in. If you plug in, I'm just going to let you know you're going to do over 0. Okay, then I'm going to try to factor. Do you see you can factor sine of x out from the top here? On the bottom, you can get x times x. I know I'm going a little fast because I'm running out of time. Guys, this right here is actually what? This right here is actually what? 0. So this is going to be 1 times 0, which is 0. Okay, this is because you've memorized these two. Okay, if you're like, where did you get that? It's because remember I told you the two things you have to memorize? You have to memorize it. Okay, guys, I'm going to move to IVT, which is what we're learning today. So we're going to go a little bit fast. Okay, sorry about that. Did you guys say Trump or Justin Bieber?
Justin Bieber.
Okay, we'll go to Justin Bieber. Okay, so you guys have to agree with me, okay, that Justin Bieber, when he was 2 years old and he was 2.8 feet, and when he was today, he's 6.4 feet, okay? Do you agree that he hit every number in between when he was growing up?
Yeah.
Right? Why? How do you know that? Because growth is a continuous function. You agree with that? Growth is a continuous function, okay? And guys, there's a calculus theorem that says if you know this y value, and you know this y value, and you know it's a continuous function, you're going to hit every y value in between, okay? And that's basically what the theorem says. The theorem says, it's called IVT, it's called the intermediate value theorem. It's actually a very important theorem in calculus. It seems really trite, okay? But it's actually very important. It says that if a function is continuous, now it only works if functions are continuous, okay? On a closed interval, then the f value, the y value, hits every value in between your other two f values. Should make a lot of sense, okay? So guys, I know you're trying to write it down, but I'm going to go on just so that you're going to be happier that I went on, FYI. This is going to be a problem that you're going to have on your. It says use the intermediate value theorem to show that if you have a function that's x squared, okay, and you're going between this interval, between x is 2 and x is 2 and 5, okay, then do you see, because this is an x squared function, the question is, will you hit 7 in between? Will you hit 7 in between? Between this point and this point, okay, as x squared grows up, will you hit 7 in between? You will. And so what you have to do is show me a proof. Okay, and let me show you how to prove this. The first thing you have to tell me is the function is continuous. Students leave this step out and they get a point off. That's okay. If you want a point off, leave it off. Okay? But it's a proof. So you have to tell me the function is continuous. The next thing you have to tell me is you have to plug in your endpoints. So plug in 2 and plug in 5 into your function. Your function is x squared. So this will be 2 squared where you get 4. This will be 5 squared where you get 25. So do you see I'm getting my two y values? Okay? And the question is 7 between those two?
Yes.
Yes. So then you have to tell me, yes, 7 is between those two values. And some students like to do this in green, which I'm happy with too. Okay? So just FYI, either or, these things are actually saying the same thing. Okay? And if you tell me that 7 is between those two y values, then the third step is you're going to say, therefore, by the IVT, by using the intermediate value theorem, 7 is on that interval. Does that make sense? Okay, 7 is on the interval. Well, you could, actually to be clear, you could say y equals 7 is on that interval. Okay? And that's how you do intermediate value theorem. Does it look easy to you?
Yes.
Yeah, it's quite easy, okay? The only tricky things they can throw in is they can say, okay, well, if 7 is on that interval, at what x value does it happen at, right? At what x value does it happen at? And then all you do is you would call this 7, solve for x, so your x would be either positive 7 or, positive square root of 7 or negative square root of 7. Do you agree with that? But guys, the x needs to be on the interval between 2 and 5. So which one would I pick? You pick the positive. You would say, okay, the answer would be x equals square root of 7. You guys good with that? Okay? And then they can throw in another twist and they could say, okay, well, use IVT not to find y equals 7, but to see if there is a 0. If there's a 0. Guys, if there's a 0, so let's say I have a function, and this is x squared plus x minus 2. Do you understand what zeros are? zeros are when not y equals 7, but when y equals what? 0. So guys, just replace the 0 with y equals 0. Okay? And then you would do the same thing. You would say, well, Ms. Chang, this is the proof. The function must be continuous to use IVT. Okay? I need to plug in my two endpoints. So you're going to plug in -1 and you're going to plug in 4 into whatever function they give you. So this will be -1 squared minus 1 minus 2, which would be -2. If you plugged in 4 here, you get 4 squared plus 4 minus 2, which is, I am not sure, is that 18? Okay, then you have to say, is y equals 0 between these two y values? When Justin Bieber was negative 2 in height, and when he was 18 in height, does 0 go between there somewhere? Yes, so you would say 0 is between -2 and 18. And again, some of you guys are rebels, so if you're a rebel, you can just say this if you don't actually want to calculate it out. Okay? But it's got to be true. Okay? And guys, wrap up your proof. Your proof would say, I use IVT to say that y equals 0 on the interval -1 to 4. Can you do that on your own? Okay, so I will post this. I know I wrote really fast. Okay, but I will post this, and this will help you guys out. Okay? I went really fast, and I just realized I didn't have to go that fast because you guys are extended time today. Too bad. I need to go back, though, because this problem here is kind of important. I need to go back and make sure that you guys can do this problem. You guys missed all my fun stuff. Okay, here we go. If I had a problem like this, what would you do first if you had this on your test?
Simplify sin x over x to be.
Yeah, before even simplifying, though, what would you try first? Plug in. Okay, plug in. So if you plug in, you're going to get 0 over 0. Okay, now what are you going to do, Reese?
Simplify sin of x over x to 1.
Kind of. You're very close. I have sin of x over x, but do you agree that this is actually what I have?
Yeah.
Okay? This is kind of like common denominator. And if you know limit properties, then this is equal to this. Right? Yeah. And this one, you know this because you've memorized this. This one's equal to 1. And what's x over x? 1. So if you plug in everywhere there's x, you plug in 0, you still get 1. So your answer is 2. You guys see how to do that? So FYI, I feel like students have a lot of trouble with these types of problems, but I just want to let you know, try to manipulate it, okay? Use all the things that you know about algebra and about trig, and see if you can simplify it enough to get an answer. And a lot of times, try to get this. Does that make sense? Like a lot of times, this will help you. Not always, okay? But get to a point where when you plug in, you can get an answer. All right, any questions on today's IVT or this trig? You guys feel good? Okay, then you guys have some time. You can work on your homework. Hopefully you picked it up. It's front and back. It's actually a lot of review. And then, I think there's 4 or 5 IVT problems on the back. Okay, and guys, this will be due tomorrow. I'll probably put up the odd solutions, okay, online. You guys can take a look at that. Let's see.